This lesson is for section 7.4. We're going to be looking at the sum and difference of cubes. So today our main objective is for you to factor the sum and difference of cubes. So we've already dealt with difference of squares. So we factored stuff in this form, a squared minus b squared, and we know that when we see something like this, we can just take that and write this as the product of two factors, a plus b and a minus b. We also know that there is no sum of squares, meaning we cannot factor a squared plus b squared because that's prime. Now, we also can factor something called a difference of cubes. So here that would be in the form a cubed minus b cubed. Now this is definitely a little bit more complex to remember than something like a plus b times a minus b. So these are the factors of a cubed minus b cubed. Notice you've got one that's a minus b, and then we have this other factor, which is a trinomial, a squared plus ab plus b squared. A sum of cubes will be in the form a cubed plus b cubed. So obviously we're calling it a sum because now we're adding the terms together. And that's going to have two factors also. It's going to look really similar to the difference of cubes where we have one factor that's a plus b. So very similar to this over here. And then your other factor will be a trinomial, a squared, this time minus ab plus b squared. So really here we have signs that are opposite of one another, while your last term here shares that same sign and it's positive. So this is something we would definitely have to memorize, so we have to know this pattern here for when we have a difference or a sum of cubes. Now, to help you remember how to put the terms into these patterns here, what I like to do is write out the terms a, which represent a cubed, right? If I took a times a, I would end up with a cubed. And then I write b, which represents b cubed. So when I see something like a cubed minus b cubed, I first identify my a and b values, and then I write them out as a and b. After that, I definitely take one factor, which I know is pretty easy to do, because all I need to do is take that term, which I've defined as a, and subtract it with b. So I'd have one factor of a minus b. Now my other factor is going to be found by using this a and b. So that other factor is found by grouping, basically groups of two, and then multiplying. So I have a times a, which gives me a squared. Then I have a times b, which gives me ab, and the last term is b times b, b squared. So again, I'm just circling every two here and grouping them together and then multiplying. Now here's where I have to remember the signs. Remember that the last term is always positive, and your term here, the ab term, is going to be the opposite of the term here, or of the sign here, which is going to make that positive. So over on the sum of cubes, if I have something in the form a cubed plus b cubed, I first identify what a and b are, and then I write out a and b. One of the factors will be simply a plus b, so that one's the easy one. And then for the other factor, I group every two here. Let me switch colors. So I will take a times a and write that as a squared. I group a and b together, the next two, and I write that as ab, and then I group the next two together, I get b squared. From here, I just remember how my signs work. The last term is always going to be positive, and this term here on the ab, it'll be the opposite of whatever is here, so it should be a negative in this case. So obviously, as you can see, I'm just repeating what you see above here. But rather than having to memorize this whole formula, we're going to just use that a, b trick. So let's begin with our first example here, which is x cubed minus 27. Now, right away, I recognize this as the difference of cubes. So I'm going to write this as DOC, the difference of cubes. Now, I know it's a difference of cubes because this term here is the quantity x cubed, and this term here is the quantity 3 cubed. So I've already identified basically the a and the b values. So here I have an a, which is x, and a b, which is 3. So now I'm going to write this as x and 3. When I factor this, I know that one of my factors will be really easy to do. That's just going to be x minus 3. So I take a and subtract b, so that would be x minus 3. Now the other factor will be found by grouping x and x together, so I get x squared, grouping x and 3 together, so that gives me 3x, and then 3 and 3 together, which gives me 9. Then for the signs here, I remember that the last term is always positive. The middle term here is going to be the opposite of this, so that makes that a positive. So what this is showing you is that x cubed minus 27, this factors into x minus 3 times x squared plus 3x plus 9. Now when we look at number 2, we definitely want to make sure that we're taking out the GCF first. So you still continue to use all of those same strategies when you try to factor. Definitely look for a GCF first here. So I would pull out that 2a, which would leave me with a cubed plus 8. Now from here, I recognize that this part here is the sum of cubes. So I'm going to write that as SOC. So here I have a sum of cubes because I can write that as a to the third power plus 2 to the third power. So that's definitely in the form a cubed plus b cubed. So I've just identified the a and the b. So here I have a equals a and b equals 2. Okay? So now when I go to factor this, I definitely know that this is going to factor down further. So I'm just going to keep that 2a here for a second. And then I'm going to do my easier factor first. Remember, don't forget, this one's kind of easy to forget about, that first factor, which will be the easier term. That's going to be a plus 2. So I've got a binomial right away, a plus 2. The second term, that one's the longer term. This is going to require me to write out that a and b. So I've got a and this time 2, 2, 2. So I will circle the first two terms, group those together, and I get a squared. Circle the next two terms, I get 2a, and then the last two terms gives me a 4. So then for the signs, I'm going to make sure that this is positive. This middle term here should be the opposite of the one out front, so that's going to be a negative here. So basically, this is the factored form of 2a to the fourth plus 16a. Now, there are a couple things I want to just forewarn you about, some mistakes that I see. Sometimes we will take off points just for the fact that students should know that these two signs should always be opposite. So if I see a plus sign and a plus sign here, even though that might to you seem very small, for us, grading that's a big mistake. That's a red flag that you don't understand how this factored form should look. So make sure that you always adjust to have these two signs being the opposite. And then of course this sign here, that's a big red flag to us as well if you make that negative, because then you're simply not remembering that should always be positive. So I see that mistake. And also a lot of people forget, like I said, to write that a plus 2 term in. But anyhow, that's our factor form for 2a to the fourth plus 16a. Alright, now numbers 3 and 4 are actually just review problems for you. This one here is going to be a difference of squares. And here, make sure you're taking out a GCF first before you realize that that's going to end up being a difference of squares problem as well. So complete those two just to make sure you're still developing those skills to be able to recognize when you have a difference of squares. And then I'm going to move on to number 5, which is also a bit of a review question, but a very important one that I want to go over with you. So we're always talking about trying to make you guys very efficient and quick problem solvers so that when you get to a test or a quiz, you're not taking forever. You can recognize patterns and you can take shortcuts. Now this is an example of a trinomial where you could split your middle term. You could find two numbers that would multiply to 36 and add up to negative 12, so that would give me negative 6 and negative 6. So I would have to break that 12xy up into negative 6xy, negative 6xy, and then obviously drop that 9y squared down. And then I could continue and try to take out the GCF and do our whole, splitting the middle term. But instead, I want you to recognize that this is a perfect square. If you look at the first term here, that's the term 2x squared, and this is the term 3y squared. Now our middle term here is 12xy, negative 12xy. Now from here I realize that the product of 2x and 3y, if I were to multiply, whoops, I don't mean to put a plus sign there. If I were to multiply those two terms, I would get 6xy. Now if I double that, I would end up with a 12xy. To get a negative 12xy, I would have to make sure that I'm subtracting the two original terms here. But basically, this is what I would have to FOIL in order to get to this. So we can simplify that and write that as 2x minus 3y squared, which means that that's a perfect square. So again, this is something that you're going to develop over time, but this is eventually what we would like you guys to realize, is that you're dealing with a perfect square trinomial here, which would factor into this. All right, next up is number 6, which I think is a pretty fun problem. Here, this is a difference of cubes. So we need to recognize this as a difference of cubes because if you look here, you've got a number cubed. That number would be 3. So 3 cubed minus, obviously the term is already cubed, but this term here, that whole thing, is just another quantity cubed. So we've got an a value of 3 and a b value of y plus 2. So don't get confused when you see something like that because it's still going to follow your same general form. You're still going to have one factor that's a minus b. So we take 3 and subtract the b term, which is y plus 2 in this case. And then we're going to write out a, so that would be 3, 3, 3. And our b term, y plus 2, and y plus 2. Now from here it's going to be a little bit different, but still the same in the sense that we're going to group 2 together. So we've got the first term would be 9. Then we'll group these next 2 together. When we multiply here, this is what I mean by it's a little bit different. We're going to have 3 times y plus 2. So when you simplify this, you will need to distribute right there. And then you're going to group the next 2. So you have y plus 2 squared. So this is the quantity y plus 2 to the second power. All right, now we're going to work on our signs. Remember, the last term is positive. That middle term here should be the opposite of the sign here, so that's going to be positive as well. All right, now let's work on simplifying. So let me erase here. To simplify this, in the first term, we're just going to simplify by distributing that negative. So we have 3 minus y minus 2, which would give me, obviously you can do that in your head, but I would write probably the number term first instead of having negative y come in front. But actually it doesn't matter. I'm not sure why I'm saying that. You can have negative y plus 1 or 1 minus y. Doesn't make a difference. I kind of prefer 1 minus y instead of seeing a negative value right away. All right, now let's work on simplifying here. This is going to give me a 9. Please don't add 9 plus 3. That's kind of like a rookie mistake here. Distribute that 3 so that you have 3y plus 6. And then here you're going to FOIL that, but obviously we can do a quick pattern here. We know that that's going to FOIL to y squared. That middle term here is going to come from doubling the product of y and 2, so 2y times 2 gives me 4y, and the last term will be this term 2 squared. Alright, so now we work on just simplifying a little bit further. I'm going to write that y squared out in front, and then I have 4y plus 3y, which gives me 7y. 9 plus 6 plus 4 gives me 19. So this here is the factored form of 27 minus y plus 2 to the third power. Now I think number 7 is a little bit tough because it's really hard to recognize at first that this is a sum of cubes. So here we have a sum of cubes because if we take 5x squared and we cube that, we would end up with 125x to the 6th. And if we take 9y and we cube this, we end up with 729y cubed. So this is definitely going to be a sum of cubes. So I'm going to for sure write out all of my a and b terms, but let's identify a. So a, we said, is 5x squared, and the b term here is going to be 9y. So the first factor is really easy. Remember, you're just going to take a plus b, so that will give me 5x squared plus 9y. Then for my second term, my second factor, I want to write out a and b. So that gives me 5x squared, 5x squared, 5x squared, and 9y, 9y, 9y. So obviously if you misidentify the a or the b term, then when you go to factor this, or to write out your next factor, you're going to have a lot of mistakes here. So this is really crucial that you identify a and b correctly. Alright, so we start here with grouping these first two. This is also where you can make some mistakes here. Remember, you're multiplying these two terms, so you're finding the product of these two, which gives you 25x to the 4th. You're going to group your next two terms, find the product here. That would be 45x squared y. Let me erase here. We're going to group the next two. That gives me 81y squared. So my last term for the signs should always be positive, and this term here, my middle term, should be the opposite of the sign out front, so that will give me a negative there. So this is the factored form of 125x to the 6th plus 729y cubed. Okay, I'd like you guys to pause and try number 8 on your own. This is going to be something I want you to check the key with because it'll be the first time you're working with a difference of cubes. So please make sure you try that one. And then number 9 here, try that one also. Now this is a review question of a difference of squares, but it's on here because I tend to notice the same mistake. Remember, when something is in the form a squared minus b squared, it'll factor into a plus b and a minus b. You can even switch the signs, right? We can switch the order of how we write these terms, but we cannot switch the order of the b and the a terms. So this is definitely not okay to write that factor here as b plus a and b minus a, because this, if we FOIL it, gives us b squared minus a squared. Notice that your term here is positive when originally it was negative, and here your term is negative when it should be positive. So something like 9 minus y squared cannot be written as y plus 3 and y minus 3. This gives me y squared minus 9, which is clearly a different sign here than the original expression that I'm trying to factor. So be careful that you're not switching your terms and you're really following this correct pattern here. Okay, now the back side of our notes is going to switch our... Now we're going to switch our focus a bit here on the back side of our notes, because now we're going to be factoring by grouping terms. So I just want to go through some strategies with you when you see something that has 4 terms with it and there's no GCF. So there's a few things that you can do to try to approach this problem. The first thing you might want to do is check to see if you can group 2 terms at a time. So I would group 2 and 2 here, and I can factor an x out of the first 2 and I get x plus 6. But out of these next 2, I can't take out a GCF. Now, some people will continue mistakenly and write that, since they think that's a difference of squares, they'll write that as 3 minus y and 3 plus y, and they'll call that a day. They'll say, okay, that's my answer. But this is definitely not factored, right? In factored form, we basically want your answer to have all parentheses, because it's a product. It's something times something times something, and maybe it's a lot of different things, but it's definitely not going to be a sum of 2 terms. So you definitely can't write that as your final answer, because that's not factored. It's not factored form. So we definitely here, I keep saying definitely, sorry, we don't want to try to group 2 terms together here, because it doesn't get us anywhere. So instead, I'm going to try to factor by grouping 3 terms together, either the first 3, so here's the hint, group terms of 3 and 1, or group terms of 1 and 3. Okay, so whichever one gives you a difference of squares is the way you're going to want to go here. So here, if I group the first 3 terms, I can recognize that as x plus 3 squared. And obviously, that, like I said, it turns into a difference of squares. And if I group the last 3 terms, there's clearly no pattern here that I can factor. So you are going to factor either, let me circle, 3 and 1, or 1 and 3. So that's after you try to see if you can group 2 and 2 as well. So those are the different ways to group. So 3 and 1, 1 and 3, or 2 and 2. Okay, I'd like you to try number 11 also on your own and check with the key. Now go through the different strategies that we talked about. Try to group 2 and 2 together, 3 and 1 together, or 1 and 3. Whichever one will be successful in turning this into a product. So make sure that your final result never has it written as a sum of different products, or even a difference of different products. You should never see these kind of signs between terms. Okay? All right, let's move on now to number 12. Okay, now in number 12, I might try at first to group 2 and 2 terms together, but that doesn't really take me anywhere. Even after I factor that difference of squares here, I'd end up with this general expression, which is definitely not factored form because of this addition symbol here, because you're adding 2 terms together. That's not going to work. So then you can go try grouping 3 and 1, and immediately that doesn't really jump out at me as any special product, so I don't recognize this as something I can factor right away. But if I look at the last 3 terms and I take out that leading negative value, you always want to make sure you factor out that negative. You have x squared minus 2xy plus y squared. So this, even though it's multivariable, is pretty easy to factor. That's just x minus y, the quantity squared. So we have 81 minus the quantity x minus y squared. And then from here, it's just a difference of squares. So we have 9 plus x minus y, and 9 minus the quantity x minus y. So if we simplify, we have 9 plus x minus y, and 9 minus x plus y. So make sure you're always distributing the negative correctly, and that would be my factored form of 81 minus x squared plus 2xy minus y squared. Alright, 13 is going to be the last problem of the lesson because I'd like you guys to try number 14 on your own and then check that one with the key. That one's going to be really similar to number 12. In number 13, you've got 4 different terms here, so you definitely want to try grouping terms together. So you can try 3 and 1, 1 and 3, and then 2 and 2. Now in this case, this is a problem where grouping 2 terms together, 2 and 2, is actually the best way to go because you can pull out a GCF here of the first 2 terms. So if I pull out that a squared, I'm left with 7x minus 6. And then from here, if I pull out that negative 1, I'm left with also 7x minus 6. So that's great. I have the same binomial here that I can now consider the GCF of this overall expression. So if I pull out the GCF here, which is 7x minus 6, I am left with a squared minus 1. Now, a lot of times I'll have a student just box this as their final answer, but you always want to double check to make sure that you don't have any difference of squares, difference of cubes, or sum of cubes left over in your final, answer, because this is definitely something that we can continue to factor. So here we would have 7x minus 6 and a plus 1 and a minus 1 as our final factor form. Okay? So again, please make sure that you're always double checking for any of these 3 things because it's easy to miss that, and then you'll get obviously points off for not continuing to factor here. Okay, that's the end of the lesson. Nice job. I'll see you guys in class tomorrow.